Hello everyone, this is Syed Mudassir Pasha with you. I'm Technical and Regional Sales Manager for Kehui International Limited, Middle East. Today we are going to learn about the concept of battery ground faults or DC earth fault identification and pinpointing system. As a protection engineer or a maintenance engineer, he knows about the importance of floating DC system, whether it is in generation, transmission or distribution network. Here you have a simple. You can see that the main DC-DB board supplies power to different loads in the substation and in turn parallelly connected with the battery source system, and batteries are parallelly charged through the battery charger system. So to avoid the heavy loss to the equipment and the industry, the power engineer always endeavors to have a normal operation of the control system without any electrical failures, and the task of identifying the faulty cores and isolating them from the source consumes time, effort, and it is no easy. And it is very important to maintain the stability of the entire DC source. If any fault occurred, it might malfunction. It might lead to malfunction of electrical assets, damage of assets or the equipment, or any other electrical failures caused due to improper maintenance, aging, insulation failure, or loose connections. So any DC floating system has a redundancy of 50% as it continues to work without disruption even if one of the polarity gets earth in course of time. The entire electrical control system along with the connecting cables and the control equipment forms a floating source. That is, at no point it is electrically connected to earth. Whereas in earth system, the system gets short-circuited in case of an earth fault with opposite polarity. Balancing network which divides the and total voltage into two equally halves and maintain the floating system. So in case of earth fault either in positive or negative polarity due to any cause, whether it is cable damage or insulation failure or improper maintenance, becomes an earth system. So it no more remains a floating system. So if you see here, you have a battery system where we show here that it's a balancing network, balancing circuit. When there is a fault occur in a positive polarity, then this fault affects the balancing circuit where it creates a voltage drop across positive to ground. So if we see this entire system in an equivalent circuit, you can see that there is a positive fault occur in a positive polarity, which in turn creates an impact on the balanced circuit of the positive voltage, positive resistance, where it drops the resistance as well as the voltage across positive to ground. So if we take a small example of a high resistive fault, so if it is a healthy system of 220 volt, you have positive to ground 110, negative to ground 110. But in case of positive high resistive fault occurred, based on the resistance, the voltage drop occurs. So if it is a high resistive voltage, you can see that the voltage drop of 30 volts here, an increase of 30 volts in the negative, but still the positive and negative remains 220 volts and the system continues to work. And there are certain cases where the system gets dead short or the positive polarity gets a low resistive fault or a dead short fault where it becomes positive to ground 0 volt and negative to ground 220 volt, and still the system positive to negative remains 220 and it works until the opposite polarity gets any fault. If the opposite polarity also gets a dead short, then the whole substation becomes blackout. So this is the equivalent circuit where there is a negative fault in a negative polarity which creates an impact on the balancing resistance of the negative negative to ground and then creates a voltage drop across negative. Same thing, if there is a high resistive faults in the negative polarity, you can see that the voltage drop in negative and increase in positive because of floating system, but still the entire system, the voltage of positive to negative remains 220 volt. So same cases can also occur that uh, the negative to ground can also be a dead short where it still remains to work until there is a fault occur in positive polarity. Switch off and switch on each feeder to see whether the system is getting stabilized or not, and also which helps to identify which feeder is faulty. So in that case, if there is any wrong feeder, if it has been switched off, it can create a lot of damage to the asset or any other electrical failures in the system. So to avoid such cases, we have launched a new online DC earth fault identification system. The main function of this equipment is to identify the healthiness of DC floating system, identify the faulty core or a faulty feeder, and pinpoint the exact fault location tracing the faulty feeder. It displays that all the parameters which is required for a protection engineer, like the balancing resistance circuit, the balancing resistance, the ground fault resistance, ground fault capacitance, and the faulty polarity, fault polarity. For example, to understand how our equipment works or how we can identify the DC earth fault in an online system, you can see here that you have a battery source which is powering the load to the providing the power to the load, and if you see there is any other earth fault occur in any polarity, consider it's a positive fault in the positive polarity. We connect our transmitter unit to the main DC-DB system and we inject a low frequency pulse into your system and we exactly locate the faulty feeder. So how do we do that? So it's a small, you can see a schematic diagram where we have connected our transmitter unit to the main DC-DB distribution board, positive and negative bus. So positive is the red and negative is the black, and we connect our equipment to the system ground. So whenever we signal into the system, the signal passes through each and every feeder and it takes a return path through ground to our equipment or the transmitter, which makes a closed loop so that we can exactly pinpoint the faulty feeder as well as the fault location. If you consider this circuit, we inject a low frequency pulse into each feeder. So this pulse goes through each and every feeder, but it takes a return path only through the fault point. So when you clamp this sensor to this feeder, which is a healthy feeder, so it doesn't get any information about the fault indication. So when you go to the faulty feeder, it gives a clear information of the leakage current as well as the injected voltage waveform. So there are certain faults which are unnoticed, like you have a multiple faults. For example, you have a fault in the positive polarity, high resistive fault in positive polarity and high resistive fault in negative polarity, which can in turn shows the balancing voltage in the circuit, but these are not noticed until there is a low resistive fault occurred in other feeders. And there are certain faults which are difficult to find. Those are multiple faults occurred in the same polarity, where you have to identify the low resistive faults first and then go to the high resistive faults. But these faults are also can be identified with our equipment. There are certain faults if you have a dual battery source system. If there is any sources which creates a lot of malfunction of the relays and other malfunctions, So those things can also be identified using this equipment. It can be either positive mixing or negative mixing of. For example, to give you a clear idea of understanding and pinpointing the fault, let us consider this single line diagram where you have two bus bars or two feeders with a bus bar connected to the load, and you can see one of the feeder is faulty. So when you clamp to a healthy feeder, you don't get any information of the leakage current and the waveform on the display. When you go to the faulty feeder, you get the clear information of the leakage current and the waveform. You need to go until the point where you reach the fault location. If you go beyond the fault location, there will be no waveform showed, which in turn gives an information that the fault is behind this point. So this helps you to exactly locate the fault location point. So if you consider there are multiple faults, this is same situation where you go on clamping each and every feeder, identify the faulty feeders, which gives a clear indication of the measured leakage current and the waveform until you reach the fault point. If there is any mixing or due to maintenance, you can clearly see that there is a mixing of fault happening at one point, which gives a information of the faulty area. So these are little bit difficult because of looping, but you can identify the fault point with this equipment. So all these kind of faults can be easily identified with our equipment. There's another important thing we need to identify, that if there is no proper grounding in your system, but you identify a fault in your DC network, you can clearly see, we can clearly identify with our equipment that the grounding is not. So how do we do that? Whenever there is a fault in the system, when you connect our equipment and if you don't get the closed loop path, it shows that the equipment or the transmitter is not connected to the proper ground, or the transmitter ground is connected to the ground where it is not grounded properly, or there is no ground point at that particular point. So if you don't get the return path, which means the grounding is improper. So coming up to the product features and specific, you have a transmitter unit, a receiver unit, a sensor. You get two different sensors with this particular supply. So this equipment helps you to identify the DC faults in the live system or online system. It also gives you the clear automatic identification of positive or negative bus voltage drops. It gives the information if there is any AC interference in the battery system. It measures your fault resistance, the capacitance of your fault capacitance, and also it gives you the information of the balancing resistance. So it has wonderful features that if this equipment can be used without external power supply, if it is 110 volts or 220 volt DC system. If you are using this equipment for 48 volt or 24 volt system, you need to have an external power supply to energize the transmitter unit.
ZDT 300 has the highest sensitivity up to 1 mega ohm for 1000 volt version and 500 kilo ohm for 500 volt version and 250 kilo ohm for 250 volt version. It has a powerful communication and real-time data transfer between the transmitter and the receiver. We provide an additional inductive sensor to clamp for a larger diameter cables, and the complete package is very effective for locating the ground faults in power utilities, railways, and telecommunication systems.
So this is the entire scope of supply for ZTD 300 DC earth fault locator. Thank you very much for watching us, and please send us your inquiries And if you need any other technical information related to your DC earth faults, you can contact us through our website www.kehui.com, or you can send us an email at info@kehui.com or smpasha@kehui.com. You can contact me with my mobile number 0559362353. Thank you very much.